just talk down them eventually.
Yeah, eventually. Yes. This week we're doing Grayson, our treasurer, is going to do a little bit of introduction into LaTeX. It's kind of like a software a lot of math majors use to write documents. Most of your textbooks are probably written in this. But some people find it easier to use physics. I know Grayson uses it for electrical engineering. It's a good way. They're going to go through a presentation that goes through all basics, and then they're going to do a little bit of lecturing to show you how to some different websites that you can write in, they're all free, and then kind of put this stuff into action. Some announcements just for like math club in general. We are not doing Power as a club, but if you want to join a club, I can participate in it. I can get in contact with people. We are doing number clubs, so if you need a club to volunteer with, we can help you with that, but if not, we're just going to have a table. That's enough for events. T-shirts, I'll take on that. You cannot know what day it's on t-shirts. It was a busy week last week. I'm hoping I can get it Monday. And then finally, we have an announcement for our next meeting. We have a sponsored talk where we have the ambassador for MATLAB coming in, and she's going to be doing a presentation on MATLAB.
What's MATLAB and C?
MATLAB is
It's only the most sophisticated calculator you can ever access.
It's like a programming language. What's your major?
Computer science.
Okay. When you get to programming languages, it's adjacent because you do MATLAB. It's math.
It's used a lot by like engineers use a ton, physicists use a ton. It's made to handle like heavyweight computations and everything. Do you recommend buying it for
You get it through tech.
Yeah, you as a student, you have a license to it.
So you don't have to worry about paying for it or anything like that.
You don't want to pay for it anyway. It's like
You probably won't ever use it outside of that class. Unless you get your
Simulator, on the other hand, is a program like kind of like a piece of MATLAB that you can use to design systems and subsystems that would model real life systems such as anything having to do with control systems, and you can use it to actually generate HDL and C code.
as a computer science school.
Yeah, if you want to put something like mechanical, industrial, any type of engineering, a lot of engineers use Simulink in order to model their systems.
the only case where CSCS student may be touching it is outside. Or if you're on some big research project and then you need computer science.
That talk is going to be October 25th, same time as now in this room, exactly. And she is bringing pizza. So starting probably Monday next week, I'm going to send an RSVP form if you plan on coming. Just like sign it, so you know how much pizza you get. So it's not like underflying or overbuying. But that's about it for announcements from me. I'm not going to talk during this. I'm going to turn it over to Greg and Grayson for the actual presentation.
So this is our introductory presentation for introduction to LaTeX. And so, yeah, we'll get right into it. So first we'll start off with what is LaTeX. So LaTeX is a typesetting system that's commonly used for basically big professional papers, typically in academia, research, or any type of scientific publishing. Anything that requires very professional software for document creation, LaTeX is your go-to. And so it's a markup language, which means that you put like a plain text input, that it also has commands, kind of like coding commands, and that describe the content that you want to output on your paper. And it's really customizable. You can even create your own custom commands that would output certain things. And there's also a lot of useful packages that you can use. It is for anything that you would really want, on like from graphing to just just circuit diagrams, really anything that you would want that you would want to look professional. There's a package for it, and it's also completely free and open source. So there's a lot of online resources that you can use to learn about it. And it's free, so you don't have to pay for it.
Okay, so why would we use LaTeX? Well, I can answer this question for me. It produces some beautiful documents. Some of the best documents I've ever written have been in LaTeX, and they look very nice. And if you want to impress somebody, you'll write in LaTeX. For example, this equation here, word equations cannot even compete with LaTeX equations, right? So I see you looking at me. Personally, I think LaTeX as a language, it feels like you're coding a document almost, but you're not. You're really writing it. You're just putting in specific commands to format it the way you want and all that. So a lot of people, whenever they get introduced to it, it scares them off because it looks like programming, but it's really not. A big benefit to it, though, is its consistent document structure and style, right? I've had a lot of documents where I've needed to write them, and instead of just reformat the document every single time, I can just copy and paste, put them together, and it carries over everything seamlessly.
And so there are a lot of different IDEs or just different ways you can access and use LaTeX. And these are a list of different ways you can do it. But the easiest way is just cloud-based, on the internet. You can access it from anywhere, from your phone, from your laptop, from any desktop computer. And what we use, especially since it's cloud-based, you can collaborate with other people at the same time. And we use Overleaf. And it's a free online website that you can go to create your own LaTeX documents. Share LaTeX is another cloud-based one. However, I personally just use Overleaf. However, if you have, especially with PowerPoint presentations and like images and things like that, you get into like longer compiling times, you would use things like TextMaker and TextStudio, which are just offline on your laptop to where, but that's specifically for just really big documents. Typically, your like lab report, thesis, anything like that, you can do it cloud-based. And so, creating a document, you start out with your document class, which would be just there's a couple that are standard. You can import more, or there's report, article, journal, book. Anyways, these may be just specific predetermined like margins, spacings, how titles look, things like that, that you would use depending on what you're making. And so,
we're gonna demo
yeah, this stuff will make a lot more sense when we get into the lab demo, and we'll show how these packages are actually used. GraphicX is just your package you need to insert images. Geometry makes it really easy to do margins and spacing. And then beginning a document, you would put all of the text that you actually want to be on the screen, on the piece of paper in that document. And that's what it would look like. Right.
Yeah, it's pretty, you know anything about programming, it's like hello world, essentially. You got something on there, congrats.
And so, you can use different commands like the title for your title. So if you need a title page for your lab report, and so you do the author, the date, and then you would use /make title in the document to actually have LaTeX create the title page for you. And then there's also a bunch of different ways that you can number pages. You can put header or footer. Headers and footers are a whole different thing. They're super customizable, just like everything else in this. We didn't include them just because that's
basically
But that's just the same margins. It's just a different way that you can set custom margins. So when you use the package for geometry, you can just set a default margin for a page, and then you can also
in that same place, you would be able to set custom margins for each side of the page. And if you wanted to make new margins for a page, you could use the geometry command.
And then 2 different ways you can enter an equation. So one is inline mode, and that's used when you want an equation to be like part of a sentence. And it's we'll show some examples of these on the next slide. And then there's also display mode, one of which produce, and that would be when you kind of want it to be off on its own in like the center of the page, to be more emphasized. And there's 2 versions of this. One which numbers the equations, and one which doesn't. It's up to whatever you would need to do in the document based on whether or not which one you'd use. And so these are the examples that I was talking about what they look like. So as you can see, the first one, that's the inline mode, where it's just a part of the sentence. And the second one is kind of by itself, is the display mode, and also off to the right, it has that equation number. And then this last one is the same thing, however, there isn't an equation number. And if I'm going too fast, we are going to be posting this lecture like in our Discord, so you'll be able to go back and look at the at this slideshow, as well as how I made this slideshow. It was in LaTeX. Okay. And then this is how you make custom commands. Oh my gosh. Yeah, you just new command. This is the definition of, this is written, right? Yeah. You just new command, call main limit definition, and then you type all that stuff in. That's just math formatting.
Yeah, the way that's saved is arbitrary. You could make it like Apple or something. Yeah. But yeah.
All right. Now on to Greg's part, which is stuff that I know nothing about. Image and graphics.
This is pretty fun because I can have more visually to share. It's not fun to do because it takes a lot of learning to do, but the results are pretty good. So there's 2 options for graphics in LaTeX. Either you generate an image outside of LaTeX and you just screenshot it, import it in, or you have LaTeX generate one through a package. We're going to start with option 1 because it's just way easier to graph onto and it's a lot more straightforward. Quite literally, we're just going to show LaTeX a folder. All right, we're going to put a file in that folder, and then we're just going to be like, hey, I want you to find this image in this folder, and then it goes grabs it, and it puts it onto your document. So yeah, we're going to be using the \graphics path command that just says, hey, LaTeX, this is where our graphics are going to be stored. And then after that, we're just going to insert images with the command include graphics, which just grabs graphics from that folder and puts them into your document. We can also do stuff like change the scaling. There's also text wrapping and all that, but I'm not going to get into that now because this is just an introduction. So you can change the scaling. You can do stuff like that. You can make it smaller, bigger. You can change the wrapping. Here's an example of it. If you get the coffee mug joke, that's awesome. As you can see, I just at the top there, this is an overlay where you see the full images, and then there's coffee donut.jpg, and then up there you can see I'm putting it out. You can see I'm putting in code, and then it's generating here. So after I scaled it, it looks like I scaled it by 0.3. So it was actually a big image, and I just forgot to change it, so to downscale it, so I did it in here. So now graphics are a bit of a different story whenever you have LaTeX generate them. So LaTeX has a package called Tix. You call it Tixie, right? Okay, I call it Tix, and it's free. You can do a ton, right? But it is very hard to learn as a learning curve. This is a whole presentation in and of its own because you have to understand what it's doing first. It takes quite a few people a while to learn it, and it's hard to understand. But it's quite similar to the equation environment. The way you begin and end it, you could or an itemized list or anything. You just say, hey, I want to put a picture here, so begin with text picture, and then you say end text picture, and then you put the picture. There's an example in here of one. Here's a simple one. You just
Drawing two lines, the point on it, right? It's an intersection point. They'll draw one line. So that's the point, and then the two lines versus backside to draw are the lines, right? This looks pretty intuitive, right? If you, I guarantee if you took like an hour or two, so it took me initially, sitting down and actually looking at documentation, you can figure it out pretty easily.
The next image was actually generated on this LaTeX document and is a different story. This took a while. Understanding what it does took a while. So if there's one thing we can learn about this is that it can do a lot. It can do a ton. It can generate anything. Like this is just an abstract image of like surface, three-dimensional space. Right? It can do a lot, but to master it is a different story because it's not exactly intuitive. But it's a whole thing. It's really cool. It can do a lot. It can graph functions. It can graph graphs. Right? It can do graphs. It can even do circuits. It can do a lot. It's just learning. It's the hard part. I think that's it, huh? Yeah.
Any questions? We also have a link to our
Okay.
Yeah, we'll get to that.
We also want to do some demo stuff as well.
We'll show it at the very end, and we'll also the source code for all this stuff will be.
I can show you. We can show you how to use Overleaf a little bit as well.
Yeah.
Because Overleaf is what we primarily use, because it's cloud-based and it's really easy to use. Honestly, I don't like installing a whole text editor on my machine.
It also has a visual editor, so if you don't like, if the code kind of freaks you out, it has a visual editor that does most everything.
Yeah, it just can't handle like equations and all that too well. No, it can handle equations. It can't make.
Yeah, I ran into Overleaf timing out when I was making a really long presentation that had a lot of pictures.
Yeah.
So like the more stuff it has to think about, the longer it takes.
Especially if it has a generator too. That's really bad. So
That's when you just download the offline thing.
and you bite the bullet and
Or you can pay Overleaf.
Yeah, it's like $10.
It's only
It's like once a month.
and if you're writing like 100-page documents, you're getting your money's worth out of it.
Yeah.
At that point, try to get the school to pay for it.
Especially if you're writing it for the university.
If you're writing it for research purposes, dish out $10.
Yeah.
Yeah. Any other questions? We'll move into the like live.
A portion of it where we'll do some demo code. There we go.
I don't think they mentioned it. They plan on doing more of these, but more central on like different aspects of
Yeah,
it.
this is quite literally an introduction
Yep.
to LaTeX.
Here, I'll zoom in a little bit. Also, I'll get rid of that.
Impress your TA, or I'm angry with you because they told you word, and
You will impress the professor, you may make the TA angry.
yeah. But really, who's the matter more the TA?
Well, the TA registered.
Yeah,
But then you can just complain.
then you complain to the professor. But if you want to impress like an employer even with like a nice document, like that's pretty good idea.
Yep.
Yeah, when I did the symposium last year, I used LaTeX for my presentation, and afterwards, a couple of people came up to me and were ecstatic that I used LaTeX. I was the only one there that used it, and that was all they
Very
talked to me
small
about.
group of people that use it, and people that do use it, it's kind of like a cult to
The
them.
symposium.
They love it so much.
We are.
Anyways,
Cold distractors.
so as you can see, when you create a document on Overleaf, if well, I created an article. So you can see it go ahead and starts it out for you. It just titles it whatever you titled the project. The author is my name, date October 2023. That's the date. And so as you can see in the document, and it has make title, it makes the title, and then you have your introduction, and then you can type in here whatever you want. We'll type it, like title it part 1, and then we can recompile, and it'll title it part 1. So,
that star we added, by the way, removes the
oh yeah,
removes the numbering. That happens for a lot of stuff on here. If you want to remove, because LaTeX will automatically number some elements, star can remove it. Captions, it's weird. You have to import a package called captions. I found that out recently. I thought that was so weird. But
yeah. As you can see, with the asterisk, without the asterisk, sections will be titled with 1, and then subsections will be 1.1. However, if you don't like this numbering system, you can just add an asterisk. It removes them. Yep. What else do you want to do for this? For the
there's different.
There's starting thing to show how you can like switch between stuff.
oh yeah. Okay. Let me on full screen. So with this right here, this side portion. This is your main file. This is where all your this is where your packages are going. This is where a lot of your packages go, as well as just your main document. This is where you're typing most of your stuff.
Images can go there as well.
Yes.
Yeah, like you can create a folder. Go ahead and create a folder.
So yeah, let's say I need to import an image or something, and then we can make a folder called images, and then within this images, I can upload any type of file, such as an image. Like let's go to images, and
that's perfect.
Yep. These are official logos of Louisiana Tech and stuff. So we'll say I wanted to import this image right here. We could go back to main, and it's flash input, right? Yeah. So we can go input. Wait, what is it? Oh, it's include graphics. Yeah, I'm used to making text files with like other text files with images in them. Yeah, include graphics. And this is a place where you can put your scale.
You can also put
That's
width,
yeah.
and those are like centimeters, inches. You can put whatever you want there.
Just to go back real quick, this is something really cool that Overleaf does. Is whenever you have this, it'll have suggested input.
And it actually shows you, hey, you have this in here in our folder, that, and it's usually if you have more files, it'll be listed there. So that's very convenient. I know. There's a lot of shortcuts with
Overleaf also has an insert
Does it?
Those 3 dots are on
Oh, dang.
Oh yeah.
There's a little picture. I use everything the hard way. That is like, that's why I don't use video.
So yeah, this there's a couple things up here that'll also help you. There's an undo redo button, bold, format italic, and then this is just an insert math button, and for the inline math and display math. And then there's a symbol palette, which requires premium. But if you actually do a short Google search, MIT has a PDF of every symbol that you can use.
Even better, if you want to use like real lines, it's usually pretty easy to figure out what they are. Just
Yeah.
and then if you want it to be capitals, you just go. It's pretty consistent with the way everything's made. There are special characters in this markup language, unfortunately, and require backslashes if you want to use them in like normal text. An example is curly brackets, because an example is like curly brackets. Those are special characters because that represents packaging for the function inputs. So if you want to use a curly bracket, you actually have to use backslash. Oh wow, what curly bracket, right?
Wait, sorry, curly bracket. Got it. My bad. Yeah, there.
So you have to put backslash in front of it. Don't put one on the end of it. If you're doing that one backslash, you'll see that it doesn't.
Oh, this right. So yeah. So as you can see down there. Yeah. And if you get rid of these backslashes, they are no longer there.
It's a little picky about everything. You're going to eventually run into a character you're going to be really confused why it doesn't work, and then you put a backslash in front of it and it works. So you have one like that was weird. And then I think I had one that same night. I can't remember what it was.
What? Because I think pound.
Yes, it was Tula. It was Tula. Yes.
Yeah. But yeah, we can also post that in the Discord, that PDF of every what's it called, command in there to just do special characters.
You don't have to Google Unicode characters. You're all at your fingertips, technically.
Yep. But here, we'll do you want to show the code for your for that one graph?
For the presentation?
Yeah. Here, I'll just go to my. This is a lot. Okay, you don't actually need all this stuff. This is just custom colors for the for this.
Some of this is unnecessary. That's racist. That wasn't me.
Yeah.
You can actually go to the slide where you're thinking.
Oh yeah, you can. So if you want to try to, if you have a really long document like I have here, and you want to go to a specific point in your document, you can double click where. What am I trying to say? Where it is on the compiled document, and it'll actually scroll down to where this is. And so this is the code for. Here, I'll do this. That's longer.
I'm not going to walk through it because it's a computer science class. But whenever I said it's not exactly intuitive to use ticks, look at this. This is all for that graphic on that last slide. This one graphic is like look at. Yeah, that's this right here. That's this right here. So it's not exactly intuitive to learn, but it is possible. It just takes a while.
I'll show off just a quick document that I made, just because I like to brag about it.
I'm just bragging about it. I'm not going to bring mine because they're just bragging about documents.
Yeah. This is just a little lab report that I did, and it, use it because it looks clean. Yeah. These are some
You
yeah.
should show how you do an equation.
Oh yeah.
Because it gets mad if you just let it type.
Yeah.
Yeah.
Real quick,
Here, we'll go back to that.
Generate graphics for like a document or something, and do not generate them and then copy and paste them into a Word document. Just write the document in LaTeX.
Don't call him out. Do not call him out. Don't call him out. Don't call him out. Don't call him out. You're gonna make me go be a 5-year engineer. Anyways, so anyways, here's how you can enter in like just a basic equation. If I have an equation they want me to enter.
I'm not going to react to it.
Go ahead, because
You don't know that? Oh my God. 2 years.
\int _a caret b. So I'm just putting it. I'm just writing it out. \int is just an integral. Quite literally, \int means integral.
So the underscore will give you the lower bound.
Yes.
And the.
That's what you meant. Okay. Yeah.
Will give you the upper bound of the integral. That's also how you write anything that would be like subscript or superscript. That's how you write that as well.
There we go. There it is. Look how pretty that is.
We can also just control plus on the right side.
here, we can just go large.
When you put it like that.
The large is the thing. Large. I don't think it is.
I noticed that the other day was that there was big. I was wondering how they did multiple things.
Anyways, yeah.